Hey there, I've been waiting. Welcome to this ADF Synapse tutorial stroke demo, because in this video, we're going to look at a practical data engineering problem. So, who is this video good for? This video is good for you if you're looking for a practical demo way of learning, or you've learned some basic of ADF and Synapse, but still don't know how to apply this in a real-world case scenario, or you're just looking to expand your knowledge in ADF and Synapse. Okay, watch until the end, because at the end of this video, I have an interesting exercise for you that will reinforce what you just learned in this demo. To get started, let's explore the problem scenario that we are going to solve in this video example. So, imagine you work for an organization and they have decided that by 2030, they need to go green, or at least reduce their carbon emission from their transport sector. Not only that, but they also want to use AI and some predictive modeling for their transport sector to predict some things they need. And that's where you step in. You go ahead and tell them, hey guys, let's use Azure, let's use Synapse, and let's use data lake or blob to do the storing of the data and everything. So what you propose is, let's copy the data from the on-prem to Azure blob, and on top of that, we will use Azure Synapse to transform the data, make it ready for the data scientist to take it over, and then also make it ready for Power BI, just visualization, to see what's the current status of our carbon emission. As we talk with the transport team, the management team sees this, and they tell us if we do a good job, then they also have other SQL databases that they might need us to copy. So we'll have to keep this in mind when building our pipeline, that our pipeline needs to be dynamic enough and reusable in a way. This is the main take of this video. So before we get started, we have to ask the transport team some main questions, which is, one, what are the connection details to the database? We have to connect to the database to copy the data. The second thing is, how many tables do you expect us to copy? Should we copy everything inside the database or just leave some? Because not all the tables might provide the information that is needed. So they then give us a list of the tables that needs to be copied. With these two, we are now ready to get started with building our pipeline. The first thing will be to visualize what exactly do we want to achieve. And one of the things that we first want is to get the list of the tables that we need to copy. Once we get the list of the tables that we want to copy in our pipeline, we need to get the database details also in our pipeline, and then use these two to check if the list of the tables that we have exist in the database. Sometimes you might get like 100 tables, and checking these tables manually is a lot of work. So I think this will be the first basic things that we should do in our pipeline before the copy is performed. If all the tables exist, then we proceed ahead to perform a copy activity for each and every table. Otherwise, we'll have to loop through this process until we get all the tables needed. Then we'll proceed ahead with the copy activity. Okay, so the first thing I've done in our Synapse is to create a mock example of a transport SQL database. And you can figure out how to create a SQL database. It doesn't have to be in Azure. You can create it on a local PC or anywhere. It will still work. So I've gone ahead and created a transport SQL database, and I've populated it with these tables. The SQL queries to create these tables is available in the link in the description. So the tables that we have are just drivers, their names, license numbers, and we have emissions. So this just shows CO2 emissions, some nitrogen oxide emissions, emission ID, blah, blah, blah. The next thing shows fuel consumptions for the vehicle and the consumption ID. So these are the tables that we will all copy, and they are available in the transport SQL database. The next thing that I have in our database is the config database. So this is ideally what will be available inside our Azure, because this is where we want to store the list of the tables that's given to us. So here I have this table called tables to copy, and it just shows that for this instant transport, these are the tables that we want to copy. And then I've added one more thing, load order, which just shows how to copy these, because we want to copy these tables sequentially based on the load order. or it might depend on which tables you want first. If you're loading and transforming the tables at the same time, some tables might be dependent on the other one. So you might want load orders depending on your transformation, or just not to overload the compute. And then the next thing that we have is this table in our Synapse, which is called database information. This just tells us that for our instance, the way we named it here, transport, we have its database is called transport, and the server is this one. The user login name is given by that, and then the secret is given by this. So this secret is not the password, but it's the secret name that will link it to the key vault. You can check out this one on how to link it to the key vault, but I will try and show on the pipeline just on an overhead basis. So now that we have these databases with a list of the tables and what we need, we can now do this inside them. So the reason why I have the username and the server inside this as a database, because it was the easiest way to actually do it. But ideally, you can have all of this inside the key vault. The reason is to retrieve a value inside the key vault. Each and every one of these will require a different web. Each and every one of these will require different web activities. So to simplify my work, or not to use the web activity at all, I've decided to put them like this in the database. Oh, if you want to use one web activity, you can save the key in the key vault as a JSON, in a JSON format, and then just retrieve one value and then find a way to split it inside the ADF. But for this video, that will be too long and we're not going to do it right now. You can experiment with that and then you tell me in the comment section how it does. So with all this being done, I think now we are ready to look into our pipeline. And first thing we said is we need to get a list of the tables to copy. We already have them inside our config DB database. We need to get the database details. We already have them inside our config DB. It would be a good idea to store your password right now inside the key vault, because that's how you should retrieve them. The second thing now, we are going to jump into the pipeline and check if the tables exist. Okay, inside our pipeline, I have created this pipeline inside Azure Synapse, but this applies also in ADF. So I have the first one called the lookup activity, and this basically just queries our config database that we created in the get database information table, DB information that we created, and returns the first row, which is just transport and the connection details. The second one queries the second table that we have in our config, which is tables to copy, and return all the rows. We then look for each table. We check if the table exists by performing a query against the source database that we have. So this one, it checks if table exists by checking the current table against the table in our source data frame. And if you just check here, you'll see that I've linked this one to our transport database. So it checks the list of tables that we have and then queries them against our transport database. I don't want to go deep into what each and every part means, but if you want the basic details, you can check Wafa studies, because you have done a whole lot of this. The only thing I'm trying to do in this video is to bring all of this together in a way that it can make sense as a project. I've then gone ahead and run this pipeline, and we can see that it checks against each and every table, and we see that all the tables exist. Looking at an example, we see here the query that it gets table name fuel types, and fuel type seems to exist because it returns the first row of the fuel type just to verify that the fuel type exists. It does this for all the tables. To experiment, you can try and add a table name that does not exist inside the transport database in your config or list of tables to copy. And now let's copy our tables, and that you just drag for each, because we want to copy each and every table, and then we can just name it for each table. And what we want to use for this one is that we wanted to get the table names, and for each table, so the items that it needs to get are from the get tables value. So get tables output, but then we want to get the value. The way to get this one is actually if you do your pipeline sequentially and debug it, you can look at what it returns, and we see that it returns output, and then we want to get that value. Okay, that's how you know what exactly should you put on the next one. And then what we want to perform for each table is a copy. Okay, so what do we want to copy? We want to copy from source. I already linked it, this one, to the source database, which is transport. And how do we know which table to copy? Remember, we're performing for each, and now we need to pass the current item dot, and the way we've named it in the config, I'm going to show you this one also in a while, table. And remember, this is just a value that I'm getting on how we passed it inside the config, because if you look again at the output, we get that the value dot table name. This is what I want to pass in. So this is the table that we want to copy. We tell it that for each and every table, we are passing the current item and then get the table name. That's what we want to copy. The sync, I've gone ahead and created a sync dataset called Parquet log, because I want to save my data as Parquet and specify the folder as production. I haven't specified this first and these ones because I want to show you something. Now if we come back to our pipeline and run it, now if we look at our container, we can see that our tables have been copied, but they have a weird name. To remove, we just have to specify some of the, we need to specify the directory and maybe the name. Do this manually and then just say transport. But because we want this to be dynamic, the best way would be add a parameter and say sync. Then instead of transport, we'll just select sync folder. And the file name, we can also add a dynamic content and then say and then add that one. So then, okay. Now when you come here, we see that we have a sync folder and the file name. So the file name, we can just take the current item dot table name, remember. But the sync folder, since we want to make this dynamic, we want that if we pass HR files that you'll have in your exercise, it copies it to the HR folder. And if you pass in transport, it copies it to the transport folder. To do this one, let's just edit our pipeline, because at this point, we just have transport and it works very well. To do so, we can add a parameter and call it instance. And for this case, we're going to say transport. And in our lookup table, instead of just getting the database details, we want to use a query, which is just a SQL, and say that select query instead to select everything where the instance, remember the column instance in our DB info is equivalent to pipeline parameter instance, so that it only returns the table so that it only returns the details for our transport instance. And we want to do the same for the tables, just in case we are going to use the same table for HR, just to get a query and then returns everything, same information. But this time we're going to query from our tables to copy, select everything from our tables to copy, where the instance is given by the pipeline instance. Then we can come back at this point and then say that the sync folder should be given by the parameter that we just passed as instance. So if we run this one, and then we provide transport and press OK, it should run OK and save everything in the folder called transport for us. And now all our tables have been copied. And if we look at our blob storage and just refresh it, we see that our transport has been copied and now they have some proper name. And we have reached the end of this video today. I hope you found it informative. And for your exercise, please try and load HR data. You're going to find a link in the description that contains the tables for HR. Try and see if you can work your way through loading this data set and reinforce what you've learned today. Your feedbacks are very valuable to me, so please tell me what you think, what should be improved in this video, and check out my other projects. We'll be looking at how to load data to Snowflakes. We'll be looking at other data science projects and data engineering projects, from Synapse to Data Robot to Azure ML. So consider subscribing. Thank you.